Homework 11, section 6.1, Discrete Random Variables, video 4. Before we move on, I want to review something that we talked about previously, because this will show up in the homework, and that's what constitutes a valid distribution. On the board, I have two distributions for two different discrete random variables. Each one can assume the values of 1 through 4. However, neither one is a valid distribution because each one has a different issue. See if you can spot what the issues are. One of them is a little more obvious than the other, the second one. What's wrong with the second one? Probability x equals 1 is 30%, probability x equals 2 is 40%, probability x equals 3 is 50%, probability x equals 4 is negative 20%. Wait, what? Oh, yeah, probabilities can't be negative. So if I took the negative off, would it be okay? The answer is still no. For the same reason this one's not. Or if it were 1.20, that would be bad also. But it can't be 1.20 and it can't be negative 20 because there are two properties of a probability distribution. Number one, all probabilities, regardless of where they come from, are between 0 and 1. So if any probability distribution has a negative probability or a probability greater than 1, then it's not a legitimate distribution. Now this one you might be thinking, well, this one's okay because all of these probabilities are between 0 and 1, but there is still something wrong with it. Can you spot what's wrong with this probability distribution? It's a little stealthy. Hint, it has to do with the sum of the probabilities. If you were to find the sum of these numbers, you would get 0.95. And what's wrong with that? What's wrong with it is that all the probabilities should add up to 100%, or as a decimal, just the number 1. So the sum here is bad because of the second property of probability, that the sum of all probabilities must equal 1. These don't. These do when the negative was up there, because 30, 40, and 50 is 120 as percents, and then minus 20% would be 100%. So this one has the correct sum, but an invalid individual probability. These have valid individual probabilities, but an invalid sum. Just kind of curious though, if I wanted to fix this one, what can I do? What can I replace this 50% with? Hint, it used to be 95%, and that's 5% too short. So if I wanted to replace the 50% with something, I would have to increase it by 5%. But more generically, you need the number that completes the sum to 100%, or the number 1. So you could add all of the other probabilities, which are 45%, subtract it from 1, and get the remaining probability of 55%. So keep in mind that not all distributions are valid distributions. All of the individual probabilities have to be between 0 and 1, and the sum of all the probabilities must equal 1.